Hi everyone, Steve Goodwin here with anchor test video number 125. Last week I gave the results of a mystery anchor that performed very, very poorly, and here it is. It is a Lewmar Claw, 10 kilogram or 23 pounds on my scale. This is a very common copy of the original Bruce anchors, and I've got some examples of the originals here so we can make some comparisons. I've got a 5, 15, 20, and 30 kilogram Bruce. I've also got a 50 kilogram Bruce that we can talk about, but it's a little big for me to lug up here onto the bench. The original Bruce anchors, I believe, were forgings, which is a much better and stronger way to shape and create metal structures. The Claw is a casting, and I believe the designers or the redesigners of the Claw were forced to make many of the thicknesses greater so that the anchor would have adequate strength. For example, the end of the shank here near the chain attach hole is really quite wide. You have to go up to the 20 kilogram genuine Bruce to get the same width. I think that was a smart move. Otherwise, there would not have been enough material here to get the needed strength. Other obvious differences are the leading edge thicknesses. Both the leading edges of the fluke toe, the wings, and also the fluke leading edge and underside. It's really quite wide and blunt on the Claw, and all of the Bruce anchors, even the big 50 kilogram Bruce, has much sharper and just better leading edges than even this 10 kilogram Claw. Here, I'll zoom in on the Claw so you can see what I'm talking about here. The thickness of this leading edge of the side fluke is really quite blunt, even a flat spot there that's wider than the width of this pencil. And then we move to the genuine Bruce. Here's the 5 kilogram, and it's just a fraction of the width of the pencil. Doesn't change much. Here's the 15. Here's the 20 kilogram genuine Bruce, and again, it's that leading edge bluntness is far less than half the width of that pencil. Same story with the 30 kilogram. Very, very sharp by comparison all along the leading edge of that side fluke. As far as the toe goes, it's exactly the same. Here we have, gosh, maybe a 1/16 of an inch of thickness, maybe a little bit more. And again, it doesn't change much. Might be a little bit thinner at the very smallest Bruce, but then when you get to the Claw, we see a very broad, flat face. And there's a bit of a taper here into the main part of the fluke, and that doesn't exist on the genuine anchors. The genuine Bruce, it's just flat from the very tip all the way back. The tip weight of the anchor in the setting position is about 34%, which is virtually identical to the genuine anchors. And Lewmar did a good job of sizing their chain attach hole. It'll accommodate 7/16 shackles, 3/8, and a 5/16 at the low end. I did get some good underwater images of this anchor doing not so well. Here's a few clips. Up first is the reset testing here in the sandy mud. Unfortunately, the anchor never sets. The toe of the fluke does engage the seabed, but the anchor cannot penetrate or bury itself at all. And because it can't set, I guess we don't really need to worry too much about how it behaves on the resetting. I did make it a couple attempts, and here's one of them. So the anchor flips over, reorientates itself, but again, no setting to speak of. Max I saw was about 200 pounds of holding, so I'm going to call it a complete failure for resetting, and while we're at it, let's just say it's a failure at holding power as well. I do give it a winch test and got a little bit more holding out of it, but nope, it's just a complete failure here in this seabed. Here are a few clips from those winch tests here in the sandy mud, and note that the anchor is on its side with one of the side flukes buried, and that's the best it ever does. In fact, once we start pulling with the winch a little bit here, the anchor rolls to nearly inverted, and it kind of oscillates between being on its side and almost upside down over and over, only making a couple 100 pounds of holding power. Little different behavior than from when those reset testing where the anchor was more upright, and I think that has to do with the boat going fast during those resets and this winch pulling at a very slow and steady speed. Both were at the same scope with the same amount of chain, so catenary should be very similar. The anchor made insufficient holding for me to conduct a veer in the sandy mud, so we will jump ahead here to the Cobblestone seabed for a straight line holding check. None of the anchors do well here. It's impossible for them to bury their shanks, so if a fluke can get fully buried, that's when usable holding starts to occur. And this one does, well, let's call it a marginal job of that. It does eventually roll upright, and it could consistently and repeatedly make about 100 pounds of holding. And once it did 135 pounds of holding. Only one other anchor in this 20-pound range of anchors did worse. That was the 17-pound Excel. It just could not get a toe under. But as you can see here, this anchor does have a buried fluke and is at least making some, albeit quite low, holding power. Here the anchor is set over in the soft mud at Scow Bay, and it is holding 315 pounds of thrust solid. And I'm using the GPS. It does read the tenths of a knot, and everything is 0 at this point. So let's just assume that anchor is solid. By comparison, there were 3 other anchors that did less holding than the claw in the soft mud here, but there were numerous anchors that were better. The very best could hold more than 600 pounds with no boat motion. Here I'm doing something a little different. Typically, as I ramp up power, when the boat speed reaches 2 knots, I cut things off. But for this time, I just let things keep going and keep ramping up power. The anchor did something pretty remarkable. It never released. I finally did shut things down when we reached 6 knots, and that was over 1,000 pounds of holding. I should say that I haven't tested the bollard pull or the thrust of the boat while it is moving. All those references or those bollard pull numbers come from the boat being tied to the dock. But let's just say it was holding or resisting a whole lot of thrust and a lot of motion, but there was no sign of that anchor releasing from the seabed. We were doing almost 6 knots, over 1,000 pounds. No sign of it releasing. Here's a speeded up clip of the veer test in the soft mud, and every 20-pound range anchor that I've tested that could hold the baseline thrust was able to execute this veer seemingly just fine. And without good underwater footage to see if the anchor was moving ahead or not, I really can't rate these on the chart, so I no longer do that. But I'll go ahead and show you that it did execute that veer. Now the straight line portion, it actually held more than the previous straight line hold check that we just saw. It held 395 pounds with no GPS motion. But as I wash off this ball of mud, we're going to see a passenger that we picked up. It is a stick that just perfectly wedged in between those 2 side flukes. The anchor did not want to release. I cut it off at 2 knots, but like in that other shot we saw, there was no sign of it releasing. Here's the 4th and final seabed we'll test the anchor in. This will be an attempt at the veering check in the clean, loose sand. The anchor lucked out with a perfectly upright deployment, so it didn't have to right itself at all here during the set, but it does not matter. The anchor never fully penetrates. Let's just say that most of the fluke does become covered with sand. And at no point did I feel that this anchor stopped moving at a 215-pound pull amount. So that's very, very poor. It is the lowest holding power of any anchor in this size range that I have tested. Here the anchor had slowed down enough to where I thought I'd try a veer, and just after 20 degrees or so, the anchor released and took off on a faster drag. By comparison, the better 20-pound range anchors could execute a full 180-degree veer at 500 pounds thrust with very little motion, and then go on to hold well over 1,000 pounds in the straight line holding portion. So clearly the claw is deficient in this clean sand as well as many other seabeds. Here's a look at my most recent ranking chart for the 20-pound range anchors. In this chart, a number 1 is the lowest score achievable, and a 5 is the highest. Down at the bottom, we see the Lewmar claw gets all number 1s with a couple number 2s in those performance categories in the middle of the chart. To the right, in the non-performance categories, the anchor does very well. Give it a 5 for price. It's a very inexpensive anchor. Strength-wise, it's very beefy. It's it's not the greatest grade of steel, but there is plenty of steel there. I don't see this anchor bending or breaking readily. Gave it a 5. Galvanizing looks good. It gets a 5, and the tip to total weight ratio is fairly high. It gets a 3. So it's those right-hand columns that give its total average, not too much lower than the other anchors, but boy, if you look at the performance average column, obviously this anchor is indeed very deficient. Here's a graphical depiction of the 20-pound range anchors in two seabeds. We've got the sandy mud resistance in the blue bars, and the green bars depict the soft mud holding power. And note that all these values are based on the anchor's holding number or resistance number divided by the anchor weight. So we've sort of normalized things for this variation in anchor weight. I've arranged them in descending order by their sandy mud performance. So we see the blue bars there descending to the right. In the far right, we do see our 23-pound claw with both a very low blue bar and a quite low green as well. One thing that's interesting to me is the way that there is an inverse correlation between the holding power in these two seabeds that are within 10 miles of each other. We see the very best sandy mud anchors are by no means the best in the soft mud, and we see the best soft mud anchors are conversely not the best in sandy mud. Well, except for the anchor's ability to remain engaged in the soft mud, it really doesn't have much going for it. There's lots of better choices. Even a second-hand genuine Bruce would be a far better anchor. Speaking of which, I've been scanning Craigslist every day here for the last couple months looking for a 10-kilogram genuine Bruce, and I just can't come up with it. There's lots of larger sizes available. Just anytime you can find a 15-kilogram and up. But again, 10 kilogram has been elusive. When I find one, though, I'll be sure to nab it and give you a side-by-side comparison. Okay, I really appreciate everyone's interest and donations to my anchor studies. As always, anchor safely. So long.